Real exam questions. This is question 53. It's about strut and ties and foundation blocks. What is the maximum permanent and mobile characteristic load on this foundation block with a crack width less than 0.3 millimeters? Ignore the check on the knots. So this is our foundation block, and we want to know what is the maximum load that this block can take. We first check the domain where we are. Is it a B domain or a D domain? Or with other words, can we use the normal formulas of reinforcement or do we use strut and tie? So for a D domain, the distance between the two reactions, L, must be smaller than 3 times the height of the depth of the block. If not, then you can just calculate it with bending moment and the concrete tables like we used to. So L is of course the 2 meters minus the 200 minus half of the width of the support is minus 100 and this 2 times. So this amount is less than 3,600. So we are in D domain and we can use strut and tie theory. The effective depth of the foundation block, which is this distance, is H, total depth, minus Y0 and minus C. So which is 1000 millimeters. The strut angle, theta, is then of course equal to 4D divided by 2L minus A0. Or you can put it more visual, it's D over 4, or it's D, sorry, D divided by L over 2 minus A0 over 4. Just to stay in this triangle. So tangent theta is 1.6. That means 58 degrees. But when theta is bigger than 55 degrees, we can increase the permissible stresses with 10%. In this question, we do not do the knot verification, so we will not further use this. Now let's have a look at the forces in ULS. So the whole system works like this is the applied load, it splits in two, half-half, and with a concrete strut, it is diverted to the two supports of the concrete block. Because this strut and this strut is divergent, then you have here compressing and there tension. So this is the reinforcement. Tension force in this tie is 5 diameter 12, so this is 5 times the area of diameter 12 times the yield strength. Gives you 246 kilonewton because working in ULS. So the yield strength is 435. Then direction force in the piles. So you start with the tension force in the reinforcement, and then you can go directly to the reaction force in the piles because this is just this tension times the tangents of theta. And this value is then 394 kilonewton. And the normal forces in the column, NED, must be in equilibrium with 2 times RCD, so it's 788 kilonewton. Now we will look at SLS, tension force in the tie, at which stress do we take this? We can now go to table 7.2n of Eurocode 2 part 1.1, and we see there the table where for 0.3 millimeter crack width, you should, for diameter 12, you should not have a bigger stress in your steel as 280 megapascal. So the total force in SLS in the tension reinforcement is the area, total area of reinforcement multiplied by the 280 stress, which gives you 158 kilonewton. Direction force in the piles, again, it is this tension force multiplied by the tangents of theta and gives you 253 kilonewton. And then we can go to the normal force in the column, because the sum of those two must be in equilibrium to the normal force of the column, and is equal to 506 kilonewton. So now we will have a look at the loads. The load in ULS is equal to 1.35 the permanent loads plus 1.5 times the permanent loads. And the total load in SLS is, of course, the permanent load plus C times PM, or 0.3 times the mobile load. But we have now calculated that this reinforcement can take 788 in ULS and 506 kilonewton in SLS. Now we have an equation, and from this equation we can calculate the characteristic value of the mobile load, which is 96 kilonewton, and the permanent load 477 kilonewton.